Dear students, I welcome you all for this refresher course on the practices component for the industrial robotics part. So today this presentation we'll just learn about 3D space tracing. Okay. So without wasting time, we'll just get into the task. So program an articulated 6-axis robot to move along a particular profile over a finite number of times on a 3D space. So this is very important, on a 3D space. So we'll understand. So before in this, we'll understand the basic part. See, what is the 3 dimension or what is the 2 dimension is? See, 3 dimension means it is x, y and then z. So 2 dimensions means usually we'll just work on x comma y. So earlier programs what we did was only with respect to x comma y. So to recall, what was the home position of the robot is 470 comma 0. But here we'll be dealing with the third dimension also. So 470 comma 0 comma 855. This is the home position of the robot. So earlier part we are discarding this z condition, that is z direction, but here we'll be doing it. So how to go ahead? It's very simple. Here we are going to do at a two distinguished level. So here we'll see a very simple application. Okay. Now we are having a square profile. So for this particular square profile, we know the coordinates, x coordinates and y coordinates. So now let me take it as default 855 in the z direction. In the z direction. So now this is layer 1. Now this is layer 1. Now either you can advance the robot or you can retract. You decide upon what you wanted to do. Now for example, I wanted to uh, advance the robot. I wanted to take the robot top on 100 mm, say 955. So here this will be say Z1 and I call this as layer 2. So here what I'll be doing is the same coordinates earlier what we did, that is for the case of the first case. Now so here it is P1, 2, 3, 4. So we know the coordinates, xy coordinates. So Z will be 855. So the same xy coordinates here, let me call this as A, B, C and D. But Z coordinates will be 955. So therefore, for layer 2, we wanted to declare 4 points. For layer 1, we wanted to declare 4 points. So total 8 points plus 1. This one is P home. So we'll be declaring all these points and we'll be doing a programming. Okay. So it is as simple as this. But you need to be very cautious enough when you program. So that we'll go through a simple example. Now, this is for the case of a prismatic part. Okay, prismatic like this, that is a cube, or to understand this is something like a simple. How do you do for the case of cylinder? Cylinder. So we know we do this by means of the command, say P1 starting point, P2 passing point, and this is P3 end point. We use the command MVC P1, P2, P3, and this is for the case of layer 1. So we wanted to have layer 2. So somewhere advance the same concept, advance by 100 mm. So here again MVC, here it will be P4, P5, P6. So where do you stop? Here the thing gets stopped. So the next point should start exactly at this particular case. So here it will be P4, P5 and here it is P6. So from here the robot will directly come to this and it will trace. So this is called as tracing in 3D. So 3-dimensional spacing we'll be working on is it. Okay. So now we'll see a very simple program. So we do for this particular activity P3, P1 to P4 and this is on layer 1. Now the same case this is for the case of layer 1 and here it is for the case of layer 2. So now we have got two particular layers. So here you fix. So here the Z value will be 855 and here it will be 955. Okay, if the height is 100. Suppose if the height is only 50, so obviously this will not be 955. In turn, it will be 905. Clear? So you look into the dimensional height, whatever the height has been given. So based on this height, we'll just go ahead with. So what is the programming part we need to take care here is, see, we start the robot, say this is the P home condition. So from the P home, you come to P1. So from there, we go to P2, then P3, then P4. Again, now you came back to P1. Clear? So this is how we finish. So exactly, then from here, we are supposed to give to the P5 point, and this point is the one which is going to connect. It is going to connect. So now what you do is, so from here you finish. Now, do you think the profile will be complete? See, 4 points on layer 1 we finished. Now we came to layer 2. So 4 points we just finished. Is it finished really? No. So here again connect to this. Ask the robot to come. From here connect to the next point. From here connect to the next point. So once you finish all the task, the pending, okay, these 3 points would have been pending that you can accomplish at the later case. So this is how we are going to do the three-dimensional spacing. Okay, students. So with this, we come to the end of this three-dimensional tracing of the robotic part. Thank you.